Thanks for all the audience joining for today's webinar. So I'm Law from Cybernet System Malaysia, Sendirian Berhad. So I'm the optical AE in the Ansys Optics software. So today I will present the automotive lighting simulation with Ansys Speos. So the design will be from the simulation driven design and validation. So this is the agenda for today's section. So the first will be introduce the Ansys Optics and also the Ansys Speo. And next, I will introduce the automotive lighting simulation key workflow. So inside this workflow, we will introduce the optical component modeling and the system validation based on the human vision. And also, we include this regulatory requirement, such as this ECE, SAE, and FMVSS. Okay, and next will be some application shortcuts, which is the interior lighting and HUD design. And the second will be the exterior lighting design. And final section will be the Q&A section. So this is the first is the multi-physics and multi-scale simulation platform. So the Ansys Optics, we consist of three software. So first is the Ansys Numerical, which is the photonic design for this nanochip level. And second will be the Ansys ZMax used for this optical design level. So all the lenses component will be designed in this software. And lastly will be the Ansys Speo. So Speo is using for the optical system modeling and validation. Okay. So for this is the application, which is the Ansys Optics. Our solution focus on the application. So we can classify into 6 major components. So first is the core package optic. Second will be the optical sensing system. And third will be the AR and VR system. And the fourth will be the display. And fifth will be the automotive, which is the vehicle today we want to mention about all the lighting and HUD. And lastly will be the laser system. So let's go to this Ansys Speo. So just now we mentioned is the optical system design and validation with human vision. So based on this software, we can import all the geometry. So we have the light modeling and analysis, and we can using the human vision and also the optical design, which is the optical part. So we can direct generate all the lenses using these tools, and the optical sensor, which is the camera, and also the important things, we doing all this optical system simulation, we need to import all the material and texture. So this material and texture will represent the optical properties of all the object inside your simulation. At the same time, we also using these tools, we can having the simulation from this UV wavelength up to this far infrared wavelength. So beside all these 6 major components, we also got this open ecosystem and also the automation, which is using the Python to automate the simulation. And we also consider the optimization, and also we having this cloud and HPC acceleration to speed up the simulation time. So for today's section, inside the Ansys Speo, for this automotive section, we will discuss about the exterior lighting, interior lighting, so maybe the color and material, and also the head-up display and the autonomous driving. Okay. So for the workflow, the automotive lighting simulation key workflow. So the first part will be the optical component modeling. So for this Ansys Speos, we support measure of the 3D file format. So as you can see, the file type can be a CAD or non-CAD, and also any CAD using the neutral format. So you can see the CAD file, we can like from CATIA, SolidWorks, and also NS or Creo, even though the Rhino. And we can export into this some others format. Okay, and also export, most of the type will be the STL and also the IGS and stat file. So for non-CAD will be the object file, the STL and the JT file. So all this is the file we support on our software import and export. So next will be the Ansys library. So this library, when we install the Ansys Pure, is come with this installation. So the installation will be the standard source, the standard material, and also the regulatory standard. So all is inside the Ansys Pure install directory. So the user can import this source material and standard into their simulation to do the simulation file. So the next one will be the optical part design. So this optical part design is the tools for the user, easier to build their lenses or the mirror or reflector. So as you can see, on the left, the three part will be the parabolic surface, the polyellipsoidal reflector, and also the optical surface. So all these three will be the surface to make the mirror using the simulator. So we just need to key in the parameter for the size and dimension and also the curvature. So the after we running the simulator, we will direct generate all this surface. And the second part will be the solid part. So which is the total internal reflection lens, the projection lens, and also the freeform lens, and some others, the array lens. As you can see, like this one is the array lenses, and this one is the optical surface. Okay, and also last one will be the light guide and HUD design. So light guide as example will be this one. So we also like in all the parameter like the the tool size here, the step size, and also we want to like add on or we extract minus inside the substrate. So all this light guide we can like setting inside the light guide tools. So when we play the simulator, then that will direct simulate the light guide into a solid. So we can save all the design time, like putting all the tools on the light guide, and also like generate the freeform lenses and TIR lenses. So this is the basic setup inside the Ansys Pure. So whenever we import the geometry into our simulation, so the first thing we need to do will be the optical and geometric properties, which is the material we need to assign to all the geometry, including the source. Okay, so next will be the sources. So from these sources, as you can see, we can apply the surface source, the ray source, and also the luminance source. And other than that, we will support also the thermic and ambient. So ambient is the environment sources for the system design is very useful. And last one will be the display. Okay, so from the sources side, we can download from this. For example, if we're using the OSRAM LED, so we can download their surface source, which is the IES and LDT file, or the ray file from the manufacturer. So we can import the ray file and also the spectrum to represent our source to the simulation. Second will be the sensor. So the sensor, as you can see, we support here will be the irradiance, the intensity, and also the radiant. So all these irradiance will be represent the lux, and the intensity represent the candela measurement, and this radiance will be the candela per meter square. Okay, and beside all these basic sensor, we also support the human eyes, which is the simulation. We are using the human eyes spectrum to do the simulation. And also we support the VR. VR can be the immersive, okay, and also the system sensor to do the simulation. And last one will be the simulation. Simulation part, we can using the direct, inverse, or the system and interactive. So most of the time, we are using the direct, and some of the sensor we can using the inverse. So the difference here will be the direct will be from the source to the sensor, but for inverse simulation, the tracking of the light ray will be from the sensor to the sources. So for the inverse only support for radiant and human eyes only, but for the direct simulation, all the sensor will be available to this simulator. Okay, and the interactive is the using the interactive source, so we can like a quick view where is the light ray go to the sensor directly. So it's a illustration, not a actual simulation. And we also having a new feature, the optimization since 2024 version. Okay, and finally, after we set up all these things, we can run the simulation. So after we run the simulation, of course, we have the result. So when we want to view the result, we can direct open from the structure tree, or we can like open the viewer and open the simulation result. So all the support things will be the photometric and also the human vision. And this virtual reality used for this AR, the VR. Okay, so now I will go through the workflow. I using an example, which is the headlamp design. So first one is the optical modeling. So we will import all the geometric design or the CAD design in, for example, like CATIA, NS, or Creo. So after we import, we can using this projection lens and also this reflector, we can use the radius or simulator. Just now I introduced inside the optical part design. So this OPD, we can direct put in all the parameters so they can generate directly based on this shape. So we can like include into our CAD and put in the actual coordinate for these things. So after this, you can see all the material is mentioned here. So we can actually input all the material and set the material into our geometry for the optical properties definition. Okay. So for this photo, illustrate the light ray propagation. So as you can see, the LED is at this direction. Or this one is the reflector. So when the light ray go to this reflector, will reflect, go to this rotor. So actually this rotor is a blocker to change the beam, the headlamp beam. Is it either the high beam or low beam? Okay. So when after we change this, so we can see the high beam will be the purple color ray, and the blue beam will be the low beam ray. So next will be the optical designer part, just now mentioned. So this one is the projector lens, so which is designed using the OPD. So whenever we input all the parameter and we set up the direction, the coordinate of this optical part, so we will direct generate this. And at the same time, the reflector, the polyellipsoidal reflector, also using the same way, you have a simulator. So we choosing all the orientation and we input all the definition for the sizing and also the curvature. So we can direct generate this reflector. So here is a video to demonstrate import the geometry. So after we import, we input a surface source and we assign the spectrum, which is the color for this LED. And also we can assign the lumen, the intensity. Okay. And next one, we will put the lenses, so which is the projector lens. So as you can see, we're using this optical part and set the coordinate for the axis, optical axis. And also we need to set up the parameter in order to create this lens. So after we set up all these things, you can see it's like real time changing the things. So now we adjust the focus, the back focus length. So after this, you can see we turn on all the geometry. Okay. So now we need to like set up all the material to all these part. So for example, the lenses, we set up this material, which is the transparent, the PMMA, to these projector lenses. And also next one will be you input the intensity sensor. So at same we do the same. We need to set the coordinate for this sensor. And after that, we need to set up. So from here, the SMP template, which is the standard we use. So you can like assign the standard directly to the sensor. So after you do the simulation, you can direct see what is passed and what is not passed according to the standard. So before we do the simulation, this is using a direct. So we need to like include all the geometric, the light source, and also the sensor. And finally, we click this play button to do the simulation. So now you can see this is the simulation result and also the standard. So which is we see that it's not passed at some of the portion. So now we adjust the back focus length to a bit front. Okay, so now we run the simulation again, and you will see the result. Okay, so this is the result, and also we can open the measurement accordingly. This is a standard template here, so you can see what is passed and what is not passed. So it's a comparison. Okay, so this is the optical analysis. So initial design, we like doing the back focus is not focus. So after that, when we put a bit longer distance for this back focus, so you can see the result before and after. And this is the optical analysis based on the colorimetric, and also this is the driver precision, which is the human vision. Okay, so this is the multi configuration for the rotating shield. So we by changing this rotating shield, we can changing the light beam height and low. Okay, so here we demonstrate how to like putting all these parameter inside for this inside the workbench, and then the rotating shield will be rotating during each simulation. So it's like this is the animation. So in actual, we will like configure one condition, and then we simulate one time, and then the second condition we simulate the next. So until the simulation finish for all the configuration. Okay, so here is the optical analysis based on we changing all these different status or condition. So you can see the light ray pattern on the illuminance and also the intensity and also the standard. So we also having the illustration when we changing the light ray in different. So you can see the low beam and then the standard low beam and high beam. So the motorway low beam. So this is all the illustration for the simulation. So next will be the design for this light guide. So it's a demonstration. So just now we demo for this projector lens and also the ellipsoidal reflector. So now we also inside the headlamp at the surrounding will be covered by the light guide. So we also demonstrate the light guide. So we'll be using these tools. So we having a line. So we need to like set up the light curve, and also we set up the optical axis. Okay, so after that, we need to like setting up the step and also the milling for the tooth of the light guide. So after that, we play this button so we can generate the tools accordingly to our setting. Okay, So the light guide is very simple. So for this is the design improvement. So in order we do the simulation in Speo. Speo inside we having the optimization tools, but based on the tools, right, we can see this is the non-optimized result. So the uniformity is quite like go to one side. So after the optimization inside the Speo, you can see the uniform side, but you also having some peak on some way. So after that, so we can using pure plus the optics length. So as you can see, the uniformity and also the peak will be quite regular and also not like having a lot of the glaring to our eyes. So here is the conclusion. So the result is 18% better and also the workflow at least 2 times faster if we're using the optics length plus this Speo. And also the workflow can be like using the program. So the programming using the Python, so no need manual interaction. So that can be like fully automate using program. Okay, so this is easier extension to robustness analysis. And here is some of the illustration for the human vision. So for human vision, just now we mentioned 3 sensor. So this is the irradiance sensor. And also the irradiance sensor, we can change to this radiance sensor. So we can get the true color or false color. So beside these 2 sensor, we also can using the human vision sensor. So which is more to the human perception, which is the spectrum sensitivity to our human eyes. So here is some of the setting inside the human vision sensor. So for example, we can like setting the precision luminance active, and also we can setting the age of the observer, and is it the observer is colorblind. Okay, and next will be the some of the setting with this human sensor. So which is the simulation parameter, for example, the depth of field, the visual acuity, and also the glare effect. So here is the colorimetric error on the human vision. So we can check using these colorimetric tools. And this is the illustration for the interior lighting. So the interior lighting, this one for the left one is the interior dashboard lighting demo. And the next one will be the light guide on the door. So this is the earlier stage ambient light design. So to know the light changing, what is the effect and also the appearance for the lit and unlit. So for the next one will be the exterior lighting development. Also, we can do the lit and unlit appearance simulation. So we can like lit the light guide, and also maybe you can like lower down the intensity of the light guide, or we can simulate all the light in lit condition during the night time. And also for the backline, the tail line also, we can doing it the same way. So lastly will be the application. Just now we mentioned the showcase. So I will show first will be the interior lighting and HUD design. And second will be the exterior lighting design. Okay, so for the first illustration of the application, this one is the specific and validate the automotive interior visual. So we can like doing the simulation to know the reflection, maybe the screen washout or the legibility on the dashboard screen, and also the viewing glare. So all this simulation we can do inside the Speo and with this human vision analysis. And also we can like interoperate with other software, and also the material modeling will be important. And also in Ansys Pure, we support on this Ansys optical library. So you can using all the material, but user also can customize using their customized material into their simulation. And the next one will be the interior lighting design. So as you can see, the light guide beside using for the exterior headlamp design. So we also can put inside the car, the So we can put on like the door, the dash cam, and even though the button here. So all this we need the support like optical measurement library. So this is the material library. So we can call it like the BSDF, the scattering distribution function, and also the scattering material. So this is optical properties. And second, the meta model optimal prognosis. So this actually is from the optics length. So as you can see, this one, the model is from optics length. So it's the optimization combination for this Speo and also the optics length. So Speo will provide the simulation result. So optics length will base on the analysis to get the uniformity of the contrast. And finally, when we're doing this simulation, do we have this combination? We want to faster the speed up the simulation or iteration. We can using the high performance computing and also the GPU inside Speos to make the simulation faster. And also we provide this accurate rendering with human vision for this kind of simulation. And next will be the head-up display, which is the HUD. So as you can see, the component development and the optimization will be done on ZMax. So just now we mentioned is one of the software doing the lenses design. So this thing will be designed in Ansys ZMax to do the lenses. So after we complete all these lenses design, we can import all these CAD into Speo to do the system design. So just now we also mentioned about the environment, the ambient. So for this illustration, you can see we can set up the ambient and also the image on the outside, like this one. So you can see the road, all the things, the view outside and also inside the car. So we can simulate the illustration, the HUD, how it perform when the human vision is included into the system. So this actually is the system simulation. And the next one will be the quality of the assessment, the precision quality. So this one, the first will be the dashboard, the screen, which is the sunlight reflection. So this one we can be minimize the critical optical effect by using the numerical. We design the film. So this is the film we design. After that, we get this BSDF, which is the material optical properties, so that we import into our Speo. So we can put it in and assign this screen using this kind of firm after our simulation. So this firm is the analysis for the firm design or surface property. So we also can identify the straight line, the ghosting, and the brightness uniformity inside the Speo. So finally, we will input all these file into Speo and the geometric and the optical properties, also the material for the surrounding. And this one, we can simulate the entire system like this photo. So this illustration actually also the human vision. So how our eyes see on this when the sunlight flash on this part. Okay, so next will be the exterior lighting design. So for the exterior lighting design, like mentioned earlier, we have this optical design part and we do the optimization. Finally, we check the regulatory requirement. So we can check on the lit and unlit and also the real-time dynamic using the AVX accelerate. Okay, so this is another software, but not inside our Ansys Optics, but it's the multi-phasic corporation, the interoperate. And next, we also mentioned earlier, so this is the lighting. So we're doing like the lit and unlit, and also the light guide to do the uniformity, find the dark spot using the human eye. And next will be the sunburn analysis on the headlamp. Okay, so you can see the projector lens. So we can do the sunlight irradiance using the environment, the ambient sensor. Okay, so today presentation will be up to here.